want you to read these 5 situations and draw free body diagrams for each. Okay, so let me draw the first one for you and then you can try the rest. Let this horizontal line be the top of the table and the box is placed here. The free body diagram shows all the forces acting on it. First, there is a force of gravity acting on it. It will be downwards. And then there's a normal force acting upwards. As the forces are equal and opposite, the box does not move at all. It continues to remain at rest. And also notice that the size of the arrows is the same. The forces are balanced and the net force is 0. Now why don't you try drawing the free body diagram for the second situation? Read it well. First things first, the force of gravity will exist and pull the box in the downward direction. As it's placed on the table, there will be an equal and opposite normal force acting upwards. Now we come to what's written. A rightward force makes the box move across the table with rightward acceleration. The word acceleration is very important here. It means the velocity is changing, and the fact that the velocity is changing implies that the forces on the box are unbalanced. The upward and the downward forces net each other off. What about the leftward and the rightward forces? Now because there is a rightward applied force, we show an arrow towards the right. Will there be any leftward force on the box? As we've been asked to ignore air resistance, it will only be the force of friction acting towards the left. And because the box is accelerating towards the right, it means that the force of friction is lesser in magnitude than the applied force towards the right. And hence the size of the arrow of the applied force is bigger than that of the frictional force. The third situation is extremely interesting. Try making its free body diagram. It says that the box is moving at a constant velocity towards the right. In any case, there will be the gravitational and normal forces acting on the box, but this time, the applied force and the frictional force will be of the same in magnitude. Hence, the size of these two arrows will be the same. As the net force is 0, the body will continue to move at that constant velocity. And don't forget, we've been asked to ignore air resistance here. Now, would you like to try drawing the free body diagrams for the fourth and the fifth situations? In the fourth case, let us first discuss the forces that are acting on the skydiver. There will be the force of gravity which is pulling the skydiver down. As there is no table or ground, the normal force will not exist. And there's no applied force on the skydiver either. But as the skydiver is falling at a constant velocity, it implies that the net force must be 0. Which is the force that will net the force of gravity? Yes, it will be the air resistance. As the velocity is constant, it implies that the magnitudes of these two forces are equal. This is the free body diagram of the fourth situation. I want you to get the fifth one right now. This is how it will look. As it's free falling, it means it's accelerating. So the magnitude of the gravitational force will be more than the magnitude of the air resistance force. With this, you've understood the basics of forces. To know more, do watch our other videos.